Hey, in this video I'm going to talk about static analysis and traditional code generation techniques that might be useful when building an app like GitWit. So let's look at a practical example first. So we have currently a very experimental feature in GitWit where if I select a component, a React component, and I go to this transformation menu, there's an extra item called move whatever the name of this component is to a new file. And if we click that, you'll see that this component actually gets replaced by an import statement, which then refers to another file where this is exported, which is going to be really useful for basically allowing people to make larger projects with multiple files. However, you'll see that the way that this is implemented right now is very hacky. So let's have a look at the source code. Here you see a file called static transformation.ts, and that's actually in the client side right now. So basically, the way this is implemented in the editor is we first we get the selected characters in the editor, and we get the text inside of that selection. And then we check to see if that is actually a React component, and then we replace it just using some pretty basic string transformation. However, the way that we're doing this right now is all very much hard-coded. We're using regular expressions to figure out what's an import statement and also even like what's a component. And we're also using hard-coded strings in order to write the code. And I think you can imagine why this might not be the best way to do it and what kind of problems could arise from doing things this way. So the question is there a better way to do this? And some research will show you that people have tried many different ways of doing this, basically editing code in a file by parsing it and then rewriting it. So now I'm going to go through a list of different tools and libraries that people have created just to do this. So first there's JSCodeShift, which is maintained by Facebook, and it's used by Facebook to basically perform migrations within their existing code base. And you can see it's fairly regularly updated. This one was last updated 4 months ago, so we know at least people are using it. And if you scroll through, at first it's a little unclear what this is, whether it's used for parsing or for migrating. But if you keep scrolling through, you'll eventually find some examples of places where this is used here. And you can see it's used in React Code Mod, JS Code Mod, which are basically libraries for performing migrations on JavaScript applications. And I've experimented a bit with that in a branch of the GitWit server, which is called transformations. And here you can see what we're actually doing here is I've defined a function called add imports, and that takes the code, the parsed code from an application, and then it adds imports to the top of the file. Same thing with add hooks. We're basically taking a block of code and then we're inserting it into the file. The thing is here we're not doing it as a string insert, we're actually doing it with parsed code. Same thing with the add component. And so we're doing this with the JSCodeShift library. And what that means is basically that we're guaranteed that the code that we're generating is real code. And we're not just sticking strings together and then checking afterwards if it really works. So that's the first thing that I tried, and that's JSCodeShift. There's also this blog article here called Say Goodbye to JSCodeShift, which is from more than 2 years ago, and it talks about some of the downsides of JSCodeShift, like no plugin support. They don't really like the syntax. Well, I find the syntax to be pretty confusing, and also they say pure maintenance and rare releases. And this article talks about why you should use a JSCodeShift alternative called Recast. Now, that sounds great. This looks a little bit easier to use, in my opinion. The only thing I would say is that here they say rare releases, and we already saw that JSCodeShift was last updated 4 months ago. Well, if you look at Recast now, that hasn't been updated for 6 months. So definitely want to take this part with a grain of salt. And then there's also a library called Grep AST. And Grep AST allows you to grep, so basically to search different code files for patterns and to find matching lines with useful context. I don't think Grep AST is intended for replacing. However, it could still be useful in some contexts. There's also a similarly named but different library called AST Grep, and that's actually meant for search and replace. It uses its own special syntax here, and so this might be something else that is worth looking into. Now, another library which is a little bit similar to this Grep AST is CTAGS. Now, what CTAGS is used for is actually looking at a whole project, and it gives you information, sort of meta information about the code in all of the files in a project. So basically, I can have CTAGS scan an entire repository and then give me basically one file, which tells me within which files are which classes, and then which functions, and the names of those functions, and the inputs and outputs, without actually including all of the code in the output. So it's really nice for a nice little summary. Now, this author, Paul Gaudier, has also used CTAGS in another project, which is called Aider. And Aider is a powerful AI assistant, which is similar to GitWit in some ways, but intended for writing any kind of code base, and is mainly intended for developers to use it at the command line. Finally, I should just mention TreeSitter, which is probably one of the most well-known tools for creating parsers for many different languages. It's extremely powerful and probably would give a greater level of control than the previous things I talked about. That said, it's probably a lot to get involved in creating something with TreeSitter, so I'm guessing that the earlier tools would be more useful. So yeah, that's just a little overview of the static analysis and traditional code generation tools. And when I say traditional, I mean pre-deep learning, AI, LLM code generation tools. And I believe that by combining these tools with LLMs, we can actually come up with something that is extremely powerful and fast if we use the right capabilities of each tool.